Concrete has existed in many forms for thousands of years. Our world is built of concrete, and concrete continues to demonstrate both longevity and architectural creativity as a building material. It's the construction material of choice for buildings, bridges, and tunnels, but its ubiquity means it has a huge environmental impact. Concrete is made from water mixed with aggregates like sand and gravel, bound together by cement. And it's the cement that is the biggest contributor to its carbon footprint. The cement industry is today one of the main producers of CO2 emissions, and the clock is ticking in the fight to reach net zero. So, what role will concrete play in the future of construction? In this episode, we find out how the leading companies in the world are taking on one of our most pressing climate challenges and making improvements to concrete production. Our first guest is Dr. Bob Slansky, who is Head of Technical Research and Innovations, Skanska, Central Europe. Welcome to Shaping Sustainable Places.
Good afternoon.
Nice to have you here. So, Bob, concrete is one of the most widely used materials in the world, yet it is also one of the single largest contributors to carbon emissions. So what is the big global picture when it comes to reduction of CO2 in concrete material? Are we on the right path?
Yes, we are on the right path, and we have to combine all possible technologies and techniques to reduce CO2 in concrete, because we are using concrete as the best material for construction, and we will use it. You can shape it to any kind of shape you like. It's quite cheap. It's quite easy to produce. It's quite easy to place. So it's a really material that all the construction guys like very much.
I see. So it's here to stay. We just have to make sure we can produce it in a way that is sustainable.
Yeah, that's true. Yeah.
So can you talk a little bit then about where is the climate impact coming from in cement and concrete?
Yeah, actually, the main impact is in the cement production. In relating to the concrete, we call it embodied carbon. In fact, that doesn't mean that carbon is physically embodied in that material, but we call it as a CO2 emissions related to the production of concrete. When transforming the limestone as a raw material to the clinker, the binder, there is a chemical reaction which we cannot reduce. The CO2 is produced and exposed to the air. It's like a natural of that. But we need cement for concrete to harden. So all the techniques lead to reducing the volume of material, reducing the use of cement, reducing the use of clinker in cement, and also use supplementary cementitious materials, and also to use alternative materials as wood and other materials.
So can you talk a little bit then about what new technologies and materials are being used to reduce the climate impact of cement and concrete?
The conventional approach is to use so-called blended cements, sometimes called also low-carbon cements. When the cement producers reduce volume of clinker in cement by adding some additives like slag or fly ash or limestone, and we can reduce the CO2 in concrete by that from 10 to 40%. So it's kind of a conventional approach.
Are there new opportunities to be able to use this kind of low-carbon concrete more widely?
In general, we can use low-carbon concrete for any applications while we are using conventional concrete. The difference is when we are replacing clinker, which is responsible for hardening concrete in time. So we are slowing down the hydration. And this is the main challenge, I would say. So we have to find out first the balance when we are designing the mix, the balance between the strength development and the CO2 reduction. And also we have to find out purposes or applications where the time is not the critical. So then we can use like a lowest CO2 concrete. And where the time is on critical paths, we cannot afford to do that. But if we want to use as much as reduction as possible, so we have to specially design the concrete mixes for these purposes, for individual structures, for the weather conditions, and taking into account also the time schedule. So it's like a more complicated, more challenging, but this is the way. And we can talk also about the non-conventional approaches. So we can use so-called supplementary cementitious materials, which are like geopolymers, natural pozzolans. They can replace partly or fully cement. And these technologies are in development. There are some pilots, and there are also some challenges with durability. We can use also substances with negative CO2 footprint. We can say this, in this case, the CO2 is physically conserved inside the material. One of the examples of that material is biochar. And this biochar is produced by pyrolysis. And there is a big development of using biochar for concrete in Skanska, Sweden. And we are in Skanska Central Europe also starting with this technology. And we can reduce the CO2 footprint of concrete over the conventional boundaries, even up to net zero concrete in some cases.
It's really quite amazing. I know that you and your team have developed something called the Rebetong concept. Is that connected to what you've been talking about? Is it something more specific?
This is something a bit different. We started this primarily not for the CO2 reduction in concrete, but as a circular solution. So to use secondary raw materials to replace and save nature aggregate. So in Rebetong, we are replacing nature aggregate by recycled aggregate, which is coming from construction demolition waste. And the results were very good. So we started the certification of the production. And the further steps in this development, which we are planning for the next year, is Rebetong new generation low carbon. So the next generation of Rebetong will be in the category of low carbon concrete as well.
Right. And what about sort of cost savings involved in that?
Yeah, you can imagine that if you don't use nature aggregate and replace it by the construction demolition waste, so you can save some money, and you can save money because the locations of the nature aggregates are usually far away from the cities. On the other hand, the recycled centers are usually inside the cities, so also you can save on the transport. But in general, we are saving, say, around 10 to 15% in cost of the material.
Okay, so you saved 10 to 15%. And at the same time, as you mentioned, over the years, you've refined and improved the blend, I guess you could say, to be more and more exactly like traditional concrete.
Yeah. That was actually our goal from the beginning, to keep the parameters as close as possible to the traditional or conventional concrete, to open the implementation to the wide variety.
Right. And so the closer it is to more traditional, the properties that you mentioned, then you have more usage for it, I guess, as well. Well, along those lines, if we think of the types of projects where this low carbon concrete has made a real impact, could make a real impact, do you have any good examples?
Yeah, I would like to mention one of our residential projects in Prague, which is called Modřanský cukrovar, previous sugar factory, brownfield. We used this pilot as a demonstration of circular and sustainable solutions in construction. So we are developing further Rebetong and its applications for structural elements. We are developing also Rebetong for facade panels. we want to show it on the facade. So the facade will be made of rebeton with grinded surface to expose the core of the material, to see the core of the material. So this is kind of a, I would say,
design element in a way.
Yeah, design element and really unique piece of the art, I would say.
Well, thank you so much for your time. I enjoyed having you.
Okay, thank you. Have a nice rest of the day.
So things are really starting to happen when it comes to reducing the CO2 emissions in concrete production. And now we're going to talk about a really exciting technology when it comes to that. With us to discuss this are two guests from Heidelberg Materials, one of the world's largest integrated manufacturers of building materials and solutions, with leading market positions in aggregates, cement, and ready-mixed concrete. Karin Comstedt-Webb is Senior Vice President for Heidelberg Materials in Sweden and also heading the ESG work for Heidelberg Materials in the Nordic region. Dr. Wolfgang Dienemann is a mineralogist and is responsible for the global research and development activities of the group, with a strong focus on CO2, but also circularity. Welcome to you both.
Thanks for having us.
Thanks a lot.
Now to some cutting-edge technology. I know that you are working on a very exciting project with the aim of reducing CO2 emissions in cement production. Can you tell me more about it, Karin?
Yes, of course. I think this is, we actually are now in a fantastic breakpoint in history, I would say, actually, where we're so close in actually deploying the very first large-scale, at industrial scale, carbon capture in cement industry. Instead of letting the CO2 up in the atmosphere through the chimney, we actually cut the chimney, reroute the gas to a, one can say, simplified chemical filter, where we actually extract the CO2 molecules and the remaining exhaust, mostly vapor, is let out. And the CO2 is then, of course, concentrated, and we are able to pressurize it so we can transport it, and it could be geologically stored. And this then has the effect, then, of course, that a large emitter is all of a sudden a non-emitter, right? So what we're going to do, what we are close in doing, is that by the end of the year, we will have actually reached what we call mechanical completion of what is the world's first project in cement industry. And that's in Brevik in Norway. And this will be then up and running during 2025, which is extremely hopeful, I would say, for the future, because it means that we demonstrate that it's possible at scale. It's possible to build a value chain of capturing at industrial side, but also combine it with partners that take care of the CO transports it and store it geologically. So A, we managed to show that it's possible, and B, we also see that we can roll it forward.
Mm-hmm. So this is happening in your plant in Brevik, Norway. Is this something that you're going to scale up to other countries as well?
Yes, of course. And I mean, for us, it's extremely important to succeed with the very first project, of course. It's a lighthouse project. It paves the way. But at the same time, when we decided to go for Brevik, we also saw the development accelerating when it comes to other projects. So we have large-scale projects being very, very close to final decisions, and that will come online, I would say, the next 5, 6, 7 years. And that's looking at Canada and the US, the UK, and also quite close to where we are right now, right here in Sweden. One of the very largest globally CCS projects will be commissioned by 2030. So this is a reality that is now being possible, I would say, because we, but also together with other partners, but also the customer side and regulators, not the least, see that this is both necessary but also possible as a response and to the climate change.
Well, anything that can get more carbon out of the atmosphere is really great, and it's exciting to hear about this world-unique industrial project. The product that will come out of this new facility in Brevik, Norway, is called Evo Zero, and it will be the world's first carbon-captured net zero cement. In fact, Skanska's just signed an agreement for this product, with delivery starting in late 2025. Can you tell us a little more about this product?
This is practically a very normal cement and doesn't require any changes in its application and also standardization or regulations. I think that is a key point which we see in, for example, using more recycled materials or using alternative SCMs, that in principle the use case determines, what are the exposure conditions, what exposure classes need to be used. And this is then in European and also national regulations clearly determines what type of cement you can use, what maximum water binder ratio you have to apply, minimum cement content, and so on and so forth. So it's not only introducing new products, but also enable their use via new regulations or standardization. So there we need much more flexibility moving forward in order to go on the continue our journey on the decarbonization side, but in the same time also regarding circularity, because also the use of recycled aggregates is limited in most countries, depending on the application, to somewhere around 30% across the board. And if we want to use the aggregates that we or recycled aggregates that come from our advanced recycling technologies, then of course we could theoretically use 100%. But this needs to find its way into standards and regulations. And that's something where we cannot work alone as an industry, but need the commitment also of the other stakeholders, the architects, the builders, to move forward on the decarbonization and the circularity route. We do that on an individual basis. We also offer in many countries so-called sustainability academy seminars, where we present or try to get transparency on the way forward and partner up with our customers.
Heidelberg puts a lot of focus on circularity. Why is circularity so important, Karin?
Yeah, I think for us as a company and for society at large, I think it's extremely important, both as a means of solving the CO2 challenge we are facing, but also, of course, the resource challenge. We do not have endless resources of everything, so we need in the construction sector to get to a point where we find good circular solutions, but also at the same time good functional products for the built environment. So that's, I think, why we put so much focus on that as a company, and we do that in various stages of the value chain. We do that internally, in-house at ours, in terms of, what can we do at cement production? Where can we bring in new materials there, both as raw materials, but also in the cement production as such. But also when we look at the concrete production, we and our customers and competitors, for that matter, are working intensively with finding new ways, new materials that fits, that actually can make a good concrete. But then also I think what's extremely important for the future and where we see the beginning of new solutions is that, when we have casted concrete and when we have a building of sorts, what can we do then? And then I think the shift in construction sector, adding more and more precast concrete solutions, there we have a huge potential of actually casting the right elements that can be building blocks for the future buildings as well. So, and we see some advancements there as well. But to summarize, it's not just one solution here, right? We have to do so many things and with so many different partners along this value chain as well.
And that brings us to our final question. I'd like you to wrap up by possibly giving us a very short idea about what you each expect as the biggest developments we're going to see in concrete and cement over, let's say, the coming 10 years.
For me, in a nutshell, the world of concrete will become more colorful. We will see cements with substantially lower clinker contents than what we are used today, with a larger variety of partly even unknown SCMs to replace clinker and reduce the clinker content. We will see a higher degree of circularity. So I guess, and that's a challenge for the entire sector, we will move away from the concept of one size of cement fits all applications. So I think there's a lot of potential to utilize very low clinker cements in less critical applications, and that is a challenge not only for the producer of the cement, but for the entire sector.
Interesting. So how can we move forward on the right path towards using concrete, Karin?
I think that you don't even have to think 10 years. I think you can actually, shorten the horizon a little bit and you will see massive changes in terms of how we work with circularity, but also the large-scale carbon capture and how these solutions will come together and really be deployed. We look at now, for example, transformation of steel sector means that you'll have new slags that will come into the cement and concrete, and that's happening. So it's also like the industrial ecosystem taking place. We look at bringing now, and we will introduce in Sweden the new pozzolanic cements that we're bringing, Icelandic pozzolanic materials to be incorporated in cement, cuts emissions with 20% in one go in the base product. That's happening right now, right? And then we have the large investments in the carbon capture projects that are lined up now. So I think it's a bit like the moment of truth, you could also say, in terms of, okay, can we as a society really come together and create the final conditions around these projects so that investment decisions can be taken and that you also see the effect in decarbonizing cement and concrete and moving towards even more circular solutions.
Karin and Wolfgang, thank you both for being on the podcast.
Thanks.
Thank you.
The future looks bright for concrete, and it will continue to play a role in the future of construction. With advancements in concrete technology, a new era of sustainable, durable, and aesthetically pleasing concrete is dawning. Dr. Bob Slansky, head of technical research and innovations with Skanska Central Europe, emphasizes that we are on the right path. But the main challenge comes from the main CO2 emitter in concrete, the clinker component of cement, which makes the concrete harden. Bob explained how the industry is moving towards specially designing concrete mixes for different use cases, for different individual structures, for the weather conditions, and taking into account time constraints. And Karin and Wolfgang see advances happening in how we work with circularity as a means of addressing carbon emissions, but also the resource challenge. And they see exciting changes coming with a large-scale adoption of carbon capture technology and how this will help the industry move towards net zero concrete. Thank you for listening. If you enjoyed this episode, make sure to subscribe so that you don't miss out in the future. If you have any thoughts about this episode or ideas for new ones to come, don't hesitate to reach out to podcast@skanska.com. We'd love to hear from you. This is a podcast from Skanska, a leading property development and construction group. To find out more about how we and others are creating healthy, resilient communities and spaces, visit us at foresight.skanska.com. I'm Emily Mandel. Thank you for joining us as we explore shaping sustainable places.